Hi everyone! In this video, we will interpret results of a hypothesis test using the critical value approach. A dietitian believes that a new weight loss supplement reduces the average body weight of users below the national average of 80 kilograms. To test this claim, a sample of 50 users is taken, and their average body weight is recorded. Given the null hypothesis is the average equals 80, and the alternative hypothesis is that the average is less than 80. With a significance level of alpha equaling 0.05, the test statistic is z equals negative 2.83, and a critical value of z sub 0.05 equals negative 1.645. Conclude whether to reject or not reject the null hypothesis and interpret the results. The first thing we need to do when working with a hypothesis test is analyze the hypotheses. Luckily, these were given to us, and the null hypothesis is that the average, or mu, equals 80, and the one that we really need to pay attention to is that the alternative says that mu is less than 80. This tells us, when we see less than, that it is a left-tailed test, and it is also pointing to the left, and all numbers that are less than 80 are also to the left. So all of those are different ways to help us remember that this is a left-tailed test. And it's easiest to visualize if we draw out a normal curve, and we are looking for a left-tailed test with an alpha, or significance level, of 0.05, making the cutoff for our rejection region. And over here by our mu, the average that equals 80, this is our fail to reject region. We were given the critical value for our alpha of equaling 0.05, so we didn't have to go look this up, and this is our critical value right here. That's the cutoff into the rejection region, and that was given to us as negative 1.645. Meaning just more than 1.5 standard deviations below the mean. So we have one standard deviation, and we'll have a second standard deviation over here. So just a little more than 1.5. This helps us to identify where our test statistic will fall, if it's in the rejection region or not. We have a test statistic of z equals negative 2.83. This is 2.83 standard deviations below the mean. So we have 1 standard deviation, 2 standard deviations, and almost 3 standard deviations below the mean for our z, or z equals, for our test score, of negative 2.83. This clearly puts us well into the rejection region, so we can make our conclusion that we are going to reject the null hypothesis. This means that there is sufficient evidence to accept or conclude the alternative. In this case, that the supplement does reduce body weight of users down to less than 80 kilograms. We've now made our conclusion whether to reject or not reject the null, and we've interpreted the results according to this hypothesis test, so we are all done.